Hello everyone. In this video, we will be discussing next topic in module 2. That is next non-traditional machining process, that is abrasive jet machining process. So first we will be discussing the uses of abrasive jet machining process, working principle, the major components present in it, and remaining things related to this we will be discussing. Generally, abrasive jet machining process, it is a cutting process, and it is an extended version of water jet cutting process, where the water jet contains abrasive particles such as silicon carbide or aluminum oxide in order to increase the metal removal rate above that of water jet machining process. Almost any type of material ranging from hard brittle materials such as ceramics, metals and glass to extremely soft materials such as foam and rubbers can be cut by abrasive water jet cutting. So this is the major use. So whenever we write the content for any non-traditional machining processes, it need not be abrasive jet machining process. It can be ultrasonic machining process, or it can be a water jet machining process, or laser beam machining process, plasma arc machining process, whatever. Always we need to start the like the content with the use. And see here, the what is the use here is hard brittle materials to the soft materials, and even soft material like foam rubbers also can be machined. You can able to see, and even hard brittle like ceramics, metals, and even brittle material like glasses also can be machined. And here, the narrow cutting stream and computer controlled movements enables this process to produce parts accurately and efficiently. And this machining process is especially ideal for cutting materials that cannot be cut by laser or thermal cut. And even we have a non-traditional machining process where the laser beam machining is also there. But even if there is any drawback in the laser machining process, even that can be overcome in the this particular process. And along with that, metallic, non-metallic and advanced composite materials of the various thicknesses can be cut by this process. And this process particularly suitable for heat sensitive materials that cannot be machined by processes that produce heat while machining. So this is also a one more important point to be noted. Whenever we do machine any like conventional non-traditional machining process, usually because of the heat some material becomes sensitive, and that leads to the some kind of shear stress on the surface. So usually that leads to the cracks and like a mild fracture. All those things will be there, but here that can be avoided because it is more of water, so that material sensitivity problems will not takes place. Then next, after the users, we need to discuss the working principle. On what principle this abrasive jet machining is working. Here you can able to see I'll be using a nozzle. We know generally what is the purpose of nozzle. Even if you take a normal water, like without any abrasive mixture, normal water, if you are allowing to pass it through the nozzle, means the velocity of like the water usually will be more. So the same purpose here, I'll be using a nozzle, but here instead of only water, where I'll be mixing up abrasives with the water. And since with the help of a pump only I'll be supplying, so the mixture already will be having some like velocity, and this velocity I'll be passing through the nozzle, so obviously it will be multiplied. So high velocity abrasive gas jet, and you can able to see like what is the velocity which I'll be allowing to pass through the nozzle. Here is 150 to 300 meter per second. That is the velocity I'll be at this particular velocity I'll be allowing the mixture of water plus abrasive slurry to this nozzle. So, and where exactly it will hit means it will exactly hit on the surface of the workpiece. And what is the distance should be maintained between the nozzle tip and the workpiece is 0.5 to 15 mm. So this is a standoff distance. We supposed to maintain this distance. Otherwise, the expected output we may not get. And this abrasive slurry is there, no, like it can able to remove of minimum zero point 0.2 to zero point 0.8 mm of like a material. It will be able to remove in each hammering, that is at each point whenever I'm hitting this slurry to the surface, it will able to remove. So since it is operated like with the help of a computer, so obviously there is no like chances of making mistakes in this particular thing. Exactly, this is a working principle, very simple working principle, where nozzle and abrasive slurry, that's all, a jet of abrasive slurry will be allowed to pass through the workpiece with a standoff distance of 0.5 to 15 mm. So now in detail we will discuss. So in abrasive jet machining process, where abrasive particles are made to impinge on the work material at a high velocity, and the jet of the abrasive particles is carried by a carrier gas or air. Here very important. Here I am using, instead of the water, sometimes even gases also I can able to use. So gases are very important, and usually water is also recommended, but in recent days where they will be using carrier gas or air. Carrier gas means usually carbon dioxide or oxygen, whatever the thing. And the high velocity stream of abrasive is generated by converting the pressure energy of the carrier gas or air to its kinetic energy, and it's hence a high velocity jet. So the nozzle directs the abrasive jet in a controlled manner onto the work material, so that the distance between the nozzle and the workpiece and the impingement angle can be set desirably. The high velocity abrasive particles remove the materials by the micro cutting action as well as the brittle fracture of the work material. And here you can able to see the setup of the abrasive jet machining process, where um, I have the major components starting from the gas supply as instead of the water. Usually nowadays we will be preferring the gases only, and the gases recommended is carbon dioxide, oxygen, and nitrogen. That is the gases recommended. Like light air also sometimes recommended. In case if I'm using air directly, means with the help of filters, we should remove the pollutants from that, and which are allowed to pass through a pipeline where a pressure regulator you can able to see this. So this pressure regulator actually it increases the pressure of the gases whatever we are using to the powder mixer, this particular drum. So this a vibrator is connected with this, and already there will be some abrasive powder in this. So once this carrier gas is entered into this particular cylinder, with the help of a vibrator, properly we will be mixing up this. Then the pressure remains same. And with the help of a food control valve, where I will be passing through this nozzle. What is the purpose of this food control valve? Means in case if I want to increase or decreasing the volume, means I can able to do that. So the nozzle already it is having some pressure, and once it is passing through the nozzle, means the jet of the abrasive what is that gas will directly hit the workpiece. You can able to see, like, once it is hitting, that means immediately it will be removed. So the angle to be maintained is only 60 to 90 degree it is recommended. So you can, the angle whatever you are seeing here is almost some 60 degree and maximum of 90 degree. If you are just going with less than 60 degree or greater than 90 degree, means the expected output we cannot able to get. And this is the hood exhaust. It is only for the coverage purpose. So the things to be remembered here is the technical informations, that is what is discussed here. The abrasive gas jet of 150 to 300 meter per second, which is allowed to pass through the nozzle, and the standoff distance, that is 0.5 to 15 mm, and the surface, the excess material which is removed of a maximum of 0.2 to 0.8 mm, it can able to remove. And in detail, the operation if you see means where the air is compressed in an air compressor, and it can be other gases too, and the compressed air at a pressure of around 5 bar is used as a carrier gas. And the sketch also just show the other major parts of the abrasive jet machining system, where gases like carbon dioxide, nitrogen also can be used as a carrier gas, which may directly be issued from a gas cylinder. So generally oxygen is not used as a carrier gas, but in very rare cases it is also recommended. The carrier gas is first passed through a pressure regulator to obtain the desired working pressure. To remove any oil, vapor, or particulate contaminant, the same is passed through a series of filters actually. Then the carrier gas enters a closed chamber known as the mixing chamber. The abrasive particles enter the chamber from a hooper through a metallic sieve. The sieve is constantly vibrated by an electromagnetic shaker, and the mass flow rate of abrasive is 15 grams per minute. Entering the chamber depends on the amplitude of vibration of the sieve and its frequency. The abrasive particles are then carried by the carrier gas to the machining chamber through an electromagnetic on-wave. So the machining enclosure is essential to contain the abrasive and the machined particles in a safe and eco-friendly manner. Finally, the machining is carried out as a high velocity, like 200 meter per second. Abrasive particles are issued from the nozzle onto a workpiece, traveling into the jet. So this is the working principle of abrasive jet machining process. In the beginning, wrongly I said it's a slurry. It is not actually slurry. It is a gas. So the abrasive is mixed with the gas. So that's all. So with this abrasive jet machining process, the major components and the working principle complete. Thank you.